Power systems are essential for the reliable and efficient generation, transmission, distribution, and consumption of electrical energy. Their study is fundamental to understanding how power flow is controlled, how voltage and frequency stability are maintained, and how modern smart grids operate in industrial and distribution environments. The smart grid power system with power generation, transmission, distribution, and loads, with SCADA, AEL-CPSS-01S, developed by EDIBON, has been designed for the comprehensive experimental study of electric power networks under real operating conditions. This application allows users to practically analyze key phenomena such as power flow, voltage and frequency regulation, grid stability, and synchronization between power generation and the electrical grid. Thanks to its modular architecture and integration with the SCADA system, the AEL-CPSS-01S provides an advanced educational and research experience that combines real-time supervision, control, and data acquisition. Its practical approach enables students, professors, and researchers to work with realistic power generation, transmission, and distribution behaviors, delivering training that is much closer to current industrial applications and smart grid environments. The application has been designed following the typical structure of a real electric power network, allowing each of its main stages to be experimentally reproduced. The power generation section is based on a synchronous motor generator set, whose speed and excitation control enables the practical study of the relationship between active power and frequency, as well as between reactive power and voltage. This approach facilitates the analysis of generator behavior both in isolated operation and when operating in parallel with the electrical grid. The study of power transmission is carried out through a transmission line module with configurable electrical parameters, allowing users to analyze how resistance, inductance, and capacitance affect voltage drop, power losses, and power transfer. The integration of step-up, regulation, and grid transformers, together with specific voltage regulation modules, reproduces real electrical power transmission and distribution conditions. Power distribution is structured through configurable busbars that enable real operating maneuvers, such as breaker opening and closing operations, load transfer, and busbar coupling. This design provides a practical understanding of electrical substation operation and the dynamic behavior of the grid under different operating configurations. The application also incorporates configurable load banks, including both passive and electronic loads, enabling the study of different consumption profiles and their influence on power factor, reactive power compensation, and the overall stability of the electrical system. For system analysis and monitoring, the AEL-CPSS-01S integrates analog measurement modules and network analyzers with data acquisition capabilities, allowing voltage, current, power, and power factor measurements to be recorded at different points throughout the installation. All these features are complemented by the SCADA system, which provides real-time supervision and control, facilitating variable visualization, event time analysis, and an advanced understanding of electrical grid behavior. This unit comes with the complete supervision, control, and data acquisition system from EDIBON, which includes a control interface and the necessary software for real-time analysis and interaction with all process parameters, as well as for managing the collected data for subsequent analysis and processing. The smart grid power system with power generation, transmission, distribution, and loads, with SCADA, AEL-CPSS-01S, allows users to carry out advanced practical exercises related to the operation, control, and analysis of modern electrical power networks. Users can work with both manual and automatic voltage and frequency control of the generator in isolated mode, gaining a practical understanding of how energy balance and grid stability are maintained under different operating conditions. The application enables the study of synchronous generator synchronization operations with the electrical grid, both manually and automatically, allowing users to analyze the procedures required to connect distributed generation to an existing network. It also makes it possible to study isolated operation and parallel operation with the grid, reproducing real scenarios commonly found in microgrids and smart grid environments. Through configurable transmission lines and distributed loads, users can analyze power flow, energy losses, the influence of line impedance, and the effect of reactive power on voltage regulation and system stability. The application also allows the study of power factor compensation and the analysis of how different types of loads affect the overall behavior of the electrical network. In addition, the AEL-CPSS-01S enables the simulation of single-phase, two-phase, and three-phase faults, with and without impedance, at different points within the electrical network. These practical exercises help users understand the response of the electrical system under real fault conditions and facilitate the study of protection strategies, service continuity, and safe grid operation. Another important feature is the possibility of performing real electrical substation maneuvers, including double busbar coupling operations, breaker and disconnector logic, load transfer, and load sharing between feeders. Through these activities, users develop practical skills related to the operation and management of complex electrical infrastructures. The integration of the SCADA system significantly expands the educational and research capabilities of the application by enabling real-time supervision of electrical variables, event recording, trend analysis, and remote control operations. This provides an immersive learning experience aligned with the technologies currently used in modern smart grids and industrial control centers. Thanks to the incredible capabilities of the SCADA software developed by EDIBON, when connected to the unit, you can easily monitor any changes in values in real time. From the comfort of the software interface, you can observe differences in the hardware and analyze all data using intuitive graphs. With advanced features such as real-time control, data monitoring, and acquisition of hundreds of data points per second, get ready to take your research or training experience to the next level with our state-of-the-art SCADA software from EDIBON. All our equipment is completely safe and can have expansions added in the future if you wish to include additional features. Thank you for watching. We hope it has been helpful. See you in the next EDIBON video.